23rd of September, around 22nd of December, the days can vary. After 23rd of September, the sun moves southwards towards the southern hemisphere, such that on around 22nd, 23rd December, the rays of the sun are vertical on the Tropic of Capricorn, right. So, the southern hemisphere experiences its summer season, while the northern hemisphere experiences its winter season. This is also termed as winter solstice, right. And the length, the period of darkness goes on increasing as one moves towards the northern pole, right. Length of day is more than length of night in the southern hemisphere, right. So, we have the equinoxes, we have the summer solstice and the winter solstice. Now, to sum up, I have given a table with the dates of the two equinoxes and the winter solstice and summer solstice. Now, what we see is the tropic after 23rd of or 22nd of December, when the sun is at the Tropic of Capricorn. What happens after this? It goes back again such that it is at its equinox position on the 21st of March, right. So, Tropic of Capricorn is marking the southern limit of the movement of the sun. Tropic of Cancer marks the northern limit, Tropic of Capricorn marks the southern limit, such that at any time during a year, the sun is always between the two tropics, right. At any time during a year, the sun is always between the two tropics. So, from 21st March equinox, it is going to the Tropic of Cancer on 21st of June. Then again, it is returning back to the equinox position on 23rd of September. Then going southwards, 23rd of December, then it again goes back. So, at any time during a year, the vertical rays of the sun appear to shine vertically between the two tropics. Vertical rays of the sunlight beyond the two tropics are not there. All the places that lie beyond the two tropics, they always receive oblique rays of the sunlight. Okay. All the places that lie beyond the two tropics, they always receive oblique rays of the sunlight and not vertical rays. Vertical sun always appears to be vertical overhead at any point between the two tropics. Right. So, what we have seen is that the sun in its apparent midday position is always between the two tropics, such that the word tropic in itself means to turn. That is, the tropics are the points from where the sun appears to turn on its northward or southward journey. The Tropic of Cancer marks the northward limit and the Tropic of Capricorn marks the southern limit, right. So, what we have discussed in this lecture, we have discussed about rotation, revolution, the tilt of the earth, the altitude of the midday sun, that is equinox and solstices. We have discussed about the varying lengths of day and night, and what causes these we have seen that the latitudes that lie beyond the two tropics, they never receive vertical rays of the sunlight, they always receive oblique rays of the sunlight. Now what is the difference? If a place is receiving vertical rays of the sunlight, there is less scattering, less diffusion, right? And the rays cover a smaller area. Now if the rays of the sun are striking a place obliquely, there is more diffusion, more scattering of the radiation by the intervening particles and contained in the atmosphere, right? So oblique rays of the sunlight always are diffused more, right, and they cover a larger area, whereas vertical rays of the sunlight, it is a large amount of radiation is striking a smaller area, right? There is less diffusion and less scattering. Now what is the consequence of this thing? The consequence of this is a phenomena that we call as the dawn and twilight. What is the dawn period? Dawn period is the small amount of light that is received before the sun rises, and twilight is a small period of light that is received after the sun sets, right? In this case, before the sun rises, in this case after the sun sets. In both the cases the sun is below the horizon, right? That is, we are not receiving perpendicular rays but oblique rays from the sun. Now it is observed that the periods of both dawn and twilight are much pronounced beyond the two tropics, right, and they are almost minimal at the equator, which receives vertical rays of the sunlight. Why is it so? Again, because of the phenomena of scattering. As equator receives vertical rays of the sunlight almost throughout the year, right, so there is less period of dawn and twilight at the equator because there is less scattering of the radiation. But as we have seen that the places that are beyond the two tropics, that are said to lie in the temperate latitudes, they receive oblique rays of the sunlight, right, and never vertical rays. So more the obliqueness of the rays, more is the scattering, therefore more is the period of dawn and twilight, right. Such that at 90° north, during the summer season of the northern hemisphere, we say that the Arctic Circle is a land of midnight sun. Why? Because there is some amount of light that shines throughout the day. It is the Arctic Circle, mind you, is not receiving vertical rays of the sunlight. It is because the scattering or diffusion or the period of dawn and twilight is very much enhanced during summer season in the northern pole region, right, because the rays are very oblique and there is more scattering. So dawn and twilight is a direct result of the scattering of the sun's radiation, almost minimal at the equator, much pronounced in the temperate latitudes, right. So this sums up the topic of dawn and twilight. Okay, now coming back to our main topic, that is, what are the reasons for seasonality. Now all of these topics that we have covered today, they act in combination for the seasons to take place, that is, Earth's rotation about its axis, Earth's revolution around the sun, the tilt of the Earth's axis, unchanging orientation of the tilt of Earth's axis. Right, this is also referred to as axial parallelism. And the last is Earth's spherical shape. So all of these are the reasons for seasonality: Earth's rotation, Earth's revolution, tilt of the Earth's axis, unchanging orientation of the tilt of Earth's axis. What this is, we'll just know after this point. And the next is Earth's spherical shape. Right. So what is unchanging orientation of Earth's axis or axial parallelism? Now as you see, if this is the sun, this is the orbit of revolution, this is your Earth, right? This is its axis. Now if you observe at all these four positions, at any given time the axis of the Earth is parallel to its position at a different time, right? So at all these four times the axis, they are parallel to each other, right? So this is the unchanging orientation of the Earth's axis. So the orientation of the Earth's axis is unchanging. This is known as axial parallelism, and this is also one of the reasons for seasonality, right? So there are two other definitions that we need to know. First is subsolar point. What is subsolar point? Subsolar point is the point where the sun is vertically overhead, right? So what is the significance of this concept? It is the point where the insolation is maximum, right? The point where the sun is directly overhead, right? And what is declination? Declination is the latitude of the subsolar point, right? The latitude of the subsolar point is the declination, sun's declination. For example, at the time of equinox, the declination, sun's declination is 0 degree. At the time of summer solstice, it is Tropic of Cancer, that is 23.5 degrees north, right? So what is the significance of declination? It is said that annually sun's declination migrates 47 degrees of latitudes, right? Now how is it? We know that tropics are the turning points of the sun's position or the sun's movement or journey, right? So 23.5 degree if you combine, so it is 47 degrees, right? So annually the sun's declination or the latitude, it migrates 47 degrees of latitudes, right? So this is about it. These are some of the important concepts related to seasonality that are often referred to in the examination. We will see in the next lecture.